last video for chapter 7. Yay. Okay. So, it's going to be kind of a little strange. This is actually really pretty easy. There's not a whole lot for us to do in this. It's really just knowing where to locate things and how to read certain output. So Minitab and another one would be JMP that you see often in this class. Minitab more popular, but basically they're statistical software packages. Okay, they produce output for data, so like slope and y-intercept, a least squares regression line. They do a lot more. It's just that we don't necessarily know that yet. Okay, so a number of statistical software packages produce similar regression output. We need to know how to locate on these outputs the slope, the y-intercept, and values of s and r squared. And eventually there is more that we need to know where it's located, but obviously we don't know it yet, so we're not going to talk about where it's located. Okay, so an output looks like this. This is a Minitab output. It looks like this, okay, where your y-intercept, okay, is going to be this first one. This is going to be a standard error. We'll talk eventually about all of this, but for right now, it's relatively useless to us, okay? So our coefficient is going to be this 3.5051, where our slope is this really small number, okay? Here's the standard deviation of our residuals, and finally, our r-squared value, okay? They say r is q. They don't give us r, so if we ever had to find r, we would have to square root r squared. Okay. So this is what a JMP output would look like, okay, where your r squared is, actually it's almost like opposite. They give you that first, okay. Here's your standard deviation of residuals, which they actually call a root mean square error, okay, which we understand this error is the idea of the standard deviation, so how much we're typically off by your mean. So where if you didn't know a y, we would use the mean of your values that you actually would have, okay. Your intercept here, right here, and your slope right here, okay. So we'll just take a look at a quick question. Okay, so a random sample of 15 high school students was selected from the U.S. Census at School database. The foot length in centimeters and height in centimeters of each student in the sample were recorded. Least squares regression was performed on the data. A scatter plot with the regression line added, a residual plot, and some computer output from the regression are shown below. Okay, so what is the equation of the least squares regression line that describes the relationship between foot length and height? And then we'll define the variables that we might use. Okay, so here's your y-intercept, and here's your slope. That's all we need here. Okay, so your predicted height of your students, that's your y, okay, would be 103.41 plus your slope 2.7469 times the foot length, which is your x, okay? So the other way of writing this would have been, whoops, I just fixed that. Okay, where y is the predicted height of the student and x is the foot length of the student. Okay. So now we'll talk about the interpretation of slope in this context, okay? Whoops. Well, that's problematic. Okay. So now how I interpret the slope, okay? So the slope is always interpreted the same way. So it's for each additional something. And it's either going to be that you're going to say the least squares regression line, or just your prediction would increase or decrease depending on whatever your slope is, okay? So for this situation in context, it would be for each additional centimeter of foot. Okay, so that's your x. The least squares regression line predicts, and your prediction is always in your height, predicts an increase, because it was a positive slope, of 2.7469 centimeters in the height. Okay, again, this is something where I'll make a fill in the blank for you guys for the interpretation, but we'll worry about that in class. Okay, we then had to find the correlation. Well, we don't have the correlation, but what we do have is r squared. So in order to find the correlation, I'm going to have to take my r squared, and I'm going to have to find the square root of it. Okay, so they tell you r squared is 48.6%. Okay, so that's 48.6% is accounted for, the variation is accounted for. So we'll have to use 0.486, okay? So we're just going to take the square root of this, okay? So r is going to equal the square root of 0.486, which is about okay. Your scatter plot had a positive direction, and so we'll just use the positive 0.697 for my correlation. Okay, and then finally, would it be appropriate to use a linear model for this data? Okay, so now I'm going to look at the residual plot. Okay, the scatter plot, first off, showed a linear association, and then the residual plot really had no obvious leftovers. Okay, this is completely random scatter all over it. Okay, so because of the random scatter in the residual plot, we'll say that there's no leftover patterns. A line is an appropriate model to use for these data. Okay. And just to kind of go through more things that we also won't really do a whole lot of, but we should understand that they are there, and they are also on our reference guide. We're almost always going to use technology to find the equation of the least squares regression line. Sometimes you don't even use technology. Sometimes they just tell you what you need and you write them. Very seldom do you have to find your slope or your y-intercept. In the case that we do, we should know what it is and kind of where it is on your reference guide, okay? But we would write, we can also write our least squares regression line, our equation of it, in terms of the means and standard deviations of the two variables and their correlation, okay? So we have data on an explanatory variable and a response variable. So from the data, we can calculate means and standard deviations of the two variables. And so we'd need to know the slope and the y-intercept based on their relationship with the means and standard deviations. Okay, so there's a real important relationship that happens between the correlation and the slope of the least squares regression line. Okay, and that is that it is the proportion of the standard deviations times your correlation, okay? And then your y-intercept. So this comes from the fact that your least squares regression line, it should always pass through your the means of both of your variables. So your least squares regression line should always pass through that, okay? And because of that, our y-intercept is found by that, okay? Not likely that you're ever going to have to do this by hand, okay? I have seen one multiple choice question with this, but it's not likely that you will need to ever calculate these things by hand. In the event that you do, though, they're not all that terrible to have to do. So let's take a look at one quick run through of them. Okay, so the mean and standard deviations of foot lengths are as follows. The mean and standard deviations of the heights are as follows. The correlation between foot length and height is 0.697. Let's find the equation of the least squares regression line. Okay, so first I have to find my slope. Okay, so 0.697 times my standard deviation of my y's, my standard deviations of my x's. So that's going to give me a slope of 2.75. Okay, and now for my y-intercept. Okay, so that's the mean of my y minus the slope times the mean of my x, which means I would have had to find my slope first. Okay. And so my a, my y-intercept, is 103.34, which means my equation of my least squares regression line is pretty much identical to what we found with the output. That's it for your videos. We'll keep discussing in class.